Hey everyone, and welcome back for another deep dive. This time we're taking a look at how machine learning is being used to classify asteroids.
Yeah, it's a pretty exciting field.
Before we get into the specifics, can you give us like a quick overview of asteroid classification, how it works and why it's important?
Sure. So basically, classifying asteroids helps us understand what they're made of, their composition. And this is crucial for a bunch of reasons. Like, it can tell us about the early solar system, how it all formed.
Right, like looking back in time.
Exactly. And it can also help us identify asteroids that might be valuable for resources, like for future mining.
Ah, space mining.
Yeah.
So how do we actually classify these asteroids?
Well, traditionally, astronomers have used what's called a taxonomic system. It's mainly based on how asteroids reflect light, their albedo, and their spectra.
So like how much light they reflect and what colors they give off?
Exactly. And based on these properties, we have three main types: C-type, S-type, and M-type.
Okay, let's break those down. What are C-type asteroids like? C-types are the most common. They're carbonaceous, which means they're rich in carbon, and they tend to be pretty dark.
Like cosmic charcoal.
Yeah, something like that. And some scientists believe they could contain water ice, which would be super valuable for future space missions.
So that's interesting. What about S-types? What makes them special?
S-types are a bit brighter than C-types. They're mostly made of silicate minerals and metals like iron and nickel.
So a bit more rocky.
Exactly.
Yeah.
And then we have the M-types, which are even more metallic. They're thought to be the remnants of the cores of larger asteroids that were smashed apart.
So like the leftovers from some epic cosmic collisions.
Right. And they could be a potential source of valuable metals if we can figure out how to mine them.
Mining asteroids, that's a whole other deep dive. But I have to imagine with all the data we're getting from telescopes and space missions, classifying asteroids can't be as simple as just looking at their color, right?
You're absolutely right. The amount of data we're collecting is growing exponentially. And it's not just the volume, it's also the complexity.
What kind of challenges does that create?
Well, for one thing, the appearance of an asteroid can change depending on the angle we're observing it from, shadows and stuff. And traditional methods can struggle to keep up with all this data and the variations in observation.
Right, so we need a more advanced approach.
Exactly. And that's where machine learning comes in.
I was hoping you'd say that. So how is machine learning changing the game when it comes to asteroid classification?
In a nutshell, machine learning algorithms can analyze huge amounts of data and find patterns that humans might miss.
Like having a superpowered asteroid detective.
Yeah, kind of. And there are different types of machine learning that are being used. One is called supervised learning.
Okay, what's that all about?
So imagine you're teaching a dog a new trick. You give it treats as rewards for doing the right thing.
I can picture that. What does that have to do with asteroids?
Well, in supervised learning, we feed the algorithm labeled data. So we show it examples of different asteroid types, C-type, S-type, M-type, and we tell it what each one is.
Ah, so we're training the algorithm to recognize those patterns, like this is what a C-type asteroid looks like. Got it.
Exactly. And once it's learned from enough examples,
Hmm.
it can then classify new, unlabeled asteroids based on their features.
That's pretty cool. What kind of algorithms are used for this supervised learning?
There are a few different ones. We have decision trees, random forests, and support vector machines. They all have their strengths and weaknesses.
Okay, let's dive into those. What are decision trees like?
Imagine a flowchart. The algorithm asks a series of questions about the asteroid, like how bright is it, or what does its spectrum look like?
So it's like a series of yes or no questions to narrow down the possibilities.
Right. And based on the answers, it branches off and eventually arrives at a classification.
Interesting. And what about random forests?
Think of it as a bunch of decision trees working together. Each tree gets a random subset of the data, and then they vote on the final classification.
So kind of like a democracy of decision trees.
Yeah, you could say that. It helps to improve the accuracy and robustness of the classification.
Makes sense. What about those support vector machines you mentioned?
So support vector machines, or SVMs, are good at drawing boundaries between different types of asteroids. They can find the optimal hyperplane, which is like a line that separates the different classes based on their features.
So it's kind of like drawing a line in the sand between a C-type asteroid and an S-type asteroid.
Exactly. And this can be especially useful for distinguishing between types that are very similar, like S-types and M-types.
So SVMs are like the border patrol of the asteroid belt, making sure everyone stays in their designated area.
That's a good way to put it. And then there's another powerful tool called artificial neural networks.
Neural networks. That sounds like something out of a sci-fi movie.
They're inspired by the human brain with interconnected nodes that process information. They're really good at handling complex data sets with lots of variables.
So are we talking about robots thinking for themselves here?
Not quite. They're still algorithms, but they're capable of learning and adapting in ways that other algorithms can't.
So they're like the brainiacs of the machine learning world.
You could say that. They're particularly good at handling noisy data, where there might be errors or inconsistencies in the observations.
So if we have a blurry picture of an asteroid, a neural network can still figure out what it is.
They're pretty amazing. And they're becoming increasingly important as we collect more and more data from space.
This is all super fascinating, but what happens if we don't even know what we're looking for? Can machines help us classify asteroids even when we haven't given them any labels?
You're talking about unsupervised learning. That's when the algorithm has to figure things out on its own without any predefined categories.
So like we give it a bunch of data about asteroids and say, go nuts, see what you can find.
Pretty much. It's like giving someone a jigsaw puzzle with no picture on the box.
That sounds like a tough job. How do those algorithms even work?
Well, one common technique is called clustering. The algorithm looks for similarities between the data points, like the asteroid's reflectance or their orbits.
So it groups together asteroids that have similar properties.
Exactly. It's like sorting a bag of marbles by color. And this can help us identify new types of asteroids that we haven't even thought of before.
So we're not just classifying known asteroids, we're actually discovering new categories.
That's the power of unsupervised learning. It can reveal hidden patterns and structures in the data.
This is all mind-blowing. But before we go any further down the rabbit hole of unsupervised learning, I think we need to take a break.
And we're back talking all about asteroid classification with machine learning.
Right, before the break, we were getting into unsupervised learning and how it can help us discover new types of asteroids.
It's pretty amazing stuff. But there's another level to machine learning we haven't even touched on yet. Deep learning.
Deep learning. Is that like the PhD level of machine learning?
You can say that. It takes inspiration from the human brain, but on a much grander scale. Imagine those neural networks we talked about earlier, but with way more layers, like a skyscraper of interconnected nodes.
So more layers, more learning.
Exactly. Deep learning algorithms can analyze incredibly complex patterns in the data. And one of the most powerful tools in this area is the convolutional neural network, or CNN.
CNN, that sounds familiar. Are those the ones that are really good at image recognition?
That's right. They're used in all sorts of applications like facial recognition and self-driving cars, but they're also proving to be incredibly useful for asteroid classification.
So we're talking about those awesome images we get from telescopes and space probes.
Exactly. CNNs can analyze those images and identify subtle features that might indicate the asteroid's composition, like variations in brightness or texture.
Wow, so it's like giving those telescopes supervision.
Kind of. And then we have another type of deep learning algorithm called a recurrent neural network, or RNN. These are great for analyzing data that changes over time.
Time series data, like how an asteroid's brightness changes as it rotates.
Exactly. RNNs can learn from those patterns and make predictions about the asteroid's future behavior.
So we're not just classifying asteroids, we're also trying to understand how they move and evolve over time.
Precisely. It's all about getting a more complete picture of these celestial objects.
This is all super exciting. But can we get down to brass tacks here? How is all this fancy technology actually being used to classify asteroids right now?
Well, there are tons of applications. For example, NASA is using ANNs to hunt for those water-rich C-type asteroids. Remember we talked about how valuable those could be for future space missions?
Yeah, those cosmic oases.
Right. Well, ANNs are helping to sift through massive amounts of data and identify those potentially valuable asteroids much faster than traditional methods.
So we're talking about speeding up the search for resources in space. What other applications are there?
Well, we can use machine learning to figure out where those asteroids are going, their orbits. We call this orbital characterization.
So we're talking about plotting those space neighborhoods, figuring out which asteroid hangs out in the main belt or ventures close to Earth.
Exactly. Using SVMs, those boundary drawing algorithms, we can classify asteroids based on their orbits and get a better sense of where they're headed.
Okay, so we can find the water-rich ones, and we know where they're going. What about those asteroid mining dreams? Can machine learning help us get our hands on some space platinum?
It's definitely making those dreams a little closer to reality. Remember PCA, the data simplifier? Well, we can combine that with clustering algorithms to locate asteroids that are rich in valuable metals.
So we're talking platinum, gold, all those precious metals that make investors drool.
Exactly. And it's not just about finding those valuable asteroids, it's also about identifying the weird ones, the outliers. We call those anomalies.
Anomalies, is that like finding a needle in a haystack?
It can be, but unsupervised learning can help us sift through all that data and find those unique asteroids with unusual compositions. Who knows what secrets they might hold?
So we're not just sorting asteroids, we're actually finding the truly special ones.
Absolutely. Machine learning is giving us a whole new way to explore the asteroid belt. But of course, there's still challenges.
Yeah, I was going to ask about that. What kind of hurdles are we facing when it comes to using machine learning for asteroid classification?
Well, data quality is a big one. Sometimes the information we get from telescopes or spacecraft can be messy or incomplete, like trying to solve a puzzle with missing pieces.
So a blurry picture or maybe a weird shadow could throw off the results.
Exactly. And we also need a lot of labeled data to train those supervised learning algorithms. If we don't have enough examples, the algorithms might not learn as effectively.
So we need more data, more labeled examples to help these algorithms reach their full potential.
Precisely. And there's also the challenge of generalization, making sure that a model trained on one data set can perform well on another data set.
So a model trained on data from one telescope might not do so well when looking at data from a different telescope.
That's right. It's something researchers are working hard to address. But even with those challenges, it's clear that machine learning is already having a huge impact on asteroid classification.
It sounds like it's revolutionizing the field. So what does the future hold for this exciting area of research?
One exciting avenue is transfer learning. Imagine taking a model that's already been trained on one data set and adapting it to analyze new data without having to start from scratch.
So instead of retraining the model from the ground up, we're giving it a crash course in a new type of asteroid data.
Exactly. It could save a ton of time and resources.
Sure.
And then there's a possibility of hybrid models, combining different machine learning techniques to achieve even better results.
So instead of just using decision trees or SVMs, we could have them all working together, like a dream team of asteroid detectives.
Precisely. And maybe the most thrilling possibility is integrating machine learning directly into space missions.
Wait, are we talking about AI-powered spacecraft making decisions about asteroids in real time?
Imagine a spacecraft that could analyze an asteroid on the fly and decide whether to study it in more detail or even mine it.
So the spacecraft becomes its own little asteroid expert? Are we really that close to this kind of technology?
It's still a vision for the future, but with all the advances in machine learning, it might be closer than we think.
I have to say, this has been an eye-opening conversation. But before we get too carried away with the future of asteroid mining and AI-powered spacecraft, I want to bring things back down to Earth for a moment. We've talked about all these amazing applications of machine learning for studying asteroids, but I have to admit, sometimes I worry about technology taking away some of the magic of space exploration. You know, that sense of wonder and awe. Do you ever feel that way?
Honestly, I think it's quite the opposite.
Yeah.
For me, machine learning is actually amplifying that sense of wonder.
Really? How so?
Well, it's like we're using these powerful tools to uncover even more mysteries, to delve deeper into the universe than ever before.
So instead of replacing human curiosity, it's enhancing it.
Exactly. Every new discovery just fuels our desire to learn more. It's like we're peeling back the layers of the cosmos, revealing incredible secrets.
I love that perspective. But let's be real, not everyone listening is an astronomer or a computer scientist. If someone wants to learn more about machine learning in space, where should they start?
Oh, there are so many great resources out there. NASA and the European Space Agency have fantastic websites with tons of information. And you can always just do a quick search online for machine learning in astronomy or asteroid classification.
What about those citizen science projects we hear about? Can people actually contribute to real research, even without a scientific background?
Absolutely. There are projects like Galaxy Zoo and Zooniverse, where you can help classify galaxies, identify exoplanets, even search for signs of extraterrestrial life,
Wow.
all from your computer.
Wow, so you don't have to be a rocket scientist to make a real contribution to space exploration.
Not at all. It's a collaborative effort, and every bit of curiosity and enthusiasm helps.
Well said. This has been an incredible journey, and I want to thank you for sharing your expertise with us. Your passion for this field is truly contagious.
Thank you. It's been a pleasure talking with you.
And to all our listeners, we hope this deep dive has sparked your curiosity about the incredible world of asteroid classification and the power of machine learning. Keep looking up at the stars, keep asking questions, and never stop exploring. Until next time.